Hi, this is a basic demonstration of using a 2-channel 2600A series system source meter unit from Keithley to characterize a MOSFET. We will generate a family of curves using the internal web page, the TSP Express software in that internal web page connected to via Ethernet. This is a useful application for people in the semiconductor industry, university researchers, and other customers. Here we have a standard 3-terminal N MOSFET. We will be using SMU-A here as a voltage source and an ammeter. It will sweep the voltage from the drain to the source. It will measure the drain current. On the other side, we have SMU-B as a voltage source and an ammeter again. It will step the gate source voltage as we go through the characterization. My 2602A is already connected via 1-to-1 Ethernet connection to my laptop with an Ethernet crossover cable. It's set up with a static IP. That's just to be used for today. Setting up the Ethernet connections for the 2600A is outside the scope of this video and will be done in a later video. So now, as you can see, I have Internet Explorer open here. So you can use this or any one of your web browsers that you choose. So just go up to the address bar and type in the address of your 2600A family instrument. Mine is 1060.471 and hit enter. Notice we'll now get a welcome page for the LXI web interface of the 2600A family. If you go off to the left side, you can see the welcome page and various other tabs here that we can go through. This video is about TSP Express, so I'll go there. Upon clicking that, this will bring up either a page that looks like you see here with the launch button, or there may be an install JRE, which is a Java runtime environment. You have to do that only once per computer, so you may need to do that before you see this launch window. Just go through the installation instructions there, and then continue on. Reboot the system, and then reopen the browser and type in the address again. You should now see the launch button. So let's click here. At the bottom here, or perhaps at a top toolbar depending on your web browser, there should be something that says, do you want to open or save this KI Java file? Let's open. This now opens up the TSP Express webpage. I'll maximize that here for our viewing. If you notice under the Quick Start, there's an option for multiple SMU sweeps and measurements. We're using 2 SMUs here to sweep on our MOSFET, so this sounds like a good starting point for us. Click that. Now this will bring up a basic window with a graphical idea of the SMU output at the very bottom and all your settings here at the top. So if you notice, the step SMU is set to SMU-A. However, on the whiteboard, we saw that it was set to SMU-B, so we need to change the SMUs here as to which is stepping and which is sweeping. This can be done in the SMU assignment button. Now, if you notice, those are already used and not in the available areas, so just highlight both and click the left arrow button to set them back to the available area. Now that we have SMU-B selected, click the right arrow to add it to the step. Do the same for sweep for SMU-A. Now click OK to save that and exit. Notice below there is a timing button. This is where you can set NPLC settings, which is your number of power line cycles that the A to D converter integrates over. Your power line cycles are either 50 Hz or 60 Hz, depending on your power line in your respective country. And you'll notice all the other delay and auto zero settings here. The default ones are fine for us, but that's where the options are, so you can see that for a later time. Click OK. Now, the step SMU is the gate SMU, so let's rename that here to gate. The sweep SMU is the drain, so let's rename that to drain. You can reset all the functions here for source, source mode, and measurement function. But we want to source on both SMUs voltage and measure current, which is the default setup, so that's fine. Going into the Advanced tab, you'll see that we can select either 2 or 4 wire, which is either local or remote sense, and set your limit I, which is the compliance current. So we'll leave that at 1 milliamp here, as that's the gate, and we shouldn't get very even close to that. Let's do the same for the drain SMU, and this MOSFET, this particular MOSFET, has 50 milliamps maximum drain current, so we'll set that to our compliance limit. Now, we want to step, from 2 volts to 5 volts on the gate. The 1 volt range isn't going to get us there, so let's go to the 6 volt range. We can set start to 2, stop to 5, and if we want 1 volt steps, that's a total of 4 steps. Measurement range, why don't we do 1 milliamp since our compliance is at 1 milliamp? We again have to go to the 6 volt range on the drain, as I want to sweep from 0 to 5 volts in 0.1 volt steps. So that'll yield 51 total points here. And the measurement range at 100 milliamps is correct because we will be setting a compliance limit of 50 milliamps, so that's appropriate here. Now let's hit the green run button, which is the arrow up at top here. We can set that, and it'll gray out until it's finished running. If we click over to the Data tab, we can see that the data is going into the table here. It's back, and now it's done. So let's display it as a graph. This looks almost like what we want, except it's a little bit off as they aren't on top of each other here, the curves. So let's change the x-axis to volts. Here, now we see a typical graph of what we expect for a family of curves for a MOSFET. We can make it a little bit zoom in or a zoom fit, or however you wish to do that here. Notice there's also an export button at the bottom here. You can export it as a CSV file, all of your data here, so that you can load it back or import it into Microsoft Excel or other spreadsheet programs that you wish to do whatever data conversion and calculations. I won't do that here, but that's just an option that I wanted to show you. So this has been a simple test showing how to use TSP Express built in the 2600A family to characterize a MOSFET. There are many other options you can do here in TSP Express or in the internal web page of the 2600A, but I hope this gets you started.